Welcome to the deep dive. We're here to sift through the sources, really dig in, and bring you the insights you need to be genuinely well informed. Today, we're tackling a subject that's, well, fundamental to every single structure we live and work in, yet it often stays hidden in plain sight, obscured by its own complexity. We're talking about building codes. Just take a second and think about the space you're in right now, the walls, the ceiling, maybe the floor beneath your feet. Every single element is shaped by this invisible, meticulously crafted framework of regulations. These aren't just random rules someone dreamed up. No, they're more like silent guardians. They're there ensuring our safety, our health, our general well-being, and they're literally baked into the fabric of our built environment. But here's the strange part, the paradox, isn't it? These codes, so incredibly critical to public health and safety, are also known for being, well, dense, often wrapped up in confusing legalistic language, and frankly, they're probably among the least understood parts of the whole construction industry. It creates this huge knowledge gap, and that gap can lead to really costly errors, frustrating delays, and much more importantly, it can compromise safety. So our mission for this deep dive is to try and demystify this crucial subject. And we're going to do that by celebrating the truly transformative work of one remarkable individual, Francis D.K. Ching. His groundbreaking work, Building Codes Illustrated, didn't just explain the rules. It fundamentally changed how people understand them. It made these complex regulations genuinely accessible to everyone, really, in a way that just hadn't been done before. So come with us on this journey. We'll explore the deep why behind these essential codes. We'll understand the challenges that come with their traditional, often quite intimidating format. We'll definitely marvel at Ching's brilliant visual solution. And then we'll dive into how his approach illuminates some of the trickiest areas of code compliance. This isn't just about learning regulations, it's really about appreciating the incredible power of clear communication to literally build a safer, more resilient world for all of us.
That's absolutely spot on. And, to really get the full impact of Ching's breakthrough, we first need a solid handle on what building codes actually are. Looking at our sources, the core definition is pretty consistent. At its most basic, a building code is a comprehensive set of legal restrictions. And these aren't suggestions, right? They are mandates. They're meticulously crafted, and their whole point is to ensure a minimum standard of health and safety in buildings. It's not about making things difficult just for the sake of it. The absolute core purpose, the heart of it all, is protecting public health, safety, and welfare. You can think of it as a fundamental societal compact, a shared agreement that the structures we design, build, and use every day have to meet certain rigorous benchmarks to prevent harm and, well, promote well-being. And what's really fascinating when you dig into it is that these aren't just arbitrary rules pulled out of thin air by some committee. Not at all. They are standards developed with incredible care, forged from, honestly, centuries of accumulated experience, and often, sadly, born from past failures and the very real human cost when buildings aren't built properly.
So they're lessons learned, essentially, codified lessons.
Exactly. While our sources don't always list specific, tragic events that led directly to every single modern code provision, the need is implicitly there. It's powerfully highlighted. Take Stuart Brand, for example. He's a keen observer of how buildings adapt and sometimes fail. He points out how certain systems, like curtain walling systems, seem to be alarmingly prone to leaks. He talks about a common design weakness, this reliance on an exposed single barrier of sealant. That become a frequent source of problems with facades, water getting in.
Oh, okay, like putting all your eggs in one basket, structurally speaking.
Precisely. Brand contrasts that with more resilient designs like the rain screen concept or using multiple layers for redundancy and reliability. The implication is clear. Simpler, flawed, or designs with single points of failure inevitably cause problems. And those problems, once they're understood, become the very reason we need formalized standards. It's a continuous feedback loop, codified for the public good.
And this isn't just a modern thing, right? This awareness goes way back.
Oh, absolutely. Way back. If you look at historical texts, this awareness of potential construction failures was deeply ingrained. Consider Vitruvius, the ancient Roman architect. He wrote extensively about building practices. He discussed the challenges of stone masonry, for instance, noting how small, porous stones could actually suck the moisture out of the mortar.
Seems like a small detail.
It does, but he explained it could lead to the ruin of the whole structure if it wasn't managed properly, like using plenty of lime and sand in the mortar mix. This isn't just some ancient trivia. It shows an early understanding of material science, right? How construction methods need to anticipate and counteract inherent weaknesses. It's like a proto-code, you could say. Or look at Joseph Moxon, writing in the 17th century. His mechanic exercises goes into incredible detail about the structural needs for something as specific as a printing press room. He stressed the need for a very firm foundation, roof, sides, the necessary braces, even down to the critical dimensions for mechanical parts like spindles.
Wow, that's specific.
It is. And all these accounts from different times, different cultures, they all point to this consistent, deeply human desire for buildings that are safe, durable, functional. Modern building codes just formalize that desire and, crucially, make it enforceable across society.
That's a really powerful connection. It makes codes feel less like bureaucracy and more like, well, a manifestation of our duty to build safely.
They absolutely are. And that connects directly to the engineers and architects' role and their societal obligation. Samuel Florman, who wrote thoughtfully about engineering, described the engineer's motivation as a responsibility to help society, a duty to use their skills for the use and convenience of man. Building codes are a direct, tangible expression of that responsibility. They translate the complex, sometimes abstract understanding of engineering and architecture, like what makes a structure stand up, how do materials behave under stress, how do systems protect us from fire or earthquakes. They translate all that into practical, enforceable rules for the public good.
So it's applied science, basically, mandated for safety.
It's exactly. Le Corbusier, the famous architect, put it quite strikingly. He said the engineer shows the way and holds the truth. He was emphasizing the scientific basis, the undeniable facts behind safe construction that codes try to capture and make mandatory. It's translating scientific truth into practical law. It's also interesting to think about how our view of this applied knowledge has changed over time. Florman mentions the old Greek idea, that thinking is better than doing.
Right, the philosopher versus the craftsman kind of thing.
Yeah, exactly.
Yeah.
Viewing the handicraft arts as somehow ignoble and vulgar. This idea that pure thought was superior to practical utilitarian goals, like actually building things. But modern society, thankfully, has moved way beyond that. We understand now, profoundly, the critical, often life-saving value of applied knowledge in construction. And that knowledge, when it's formalized by codes, literally builds safer communities, protects huge investments, and ensures our buildings actually work and last. It's where the abstract idea of societal safety meets the concrete reality of steel and concrete, all guided by shared best practices.
Okay, that really establishes the why. Codes are absolutely essential. But let's pivot to the how. How do people actually use these documents? Because, let's be honest, while the purpose is vital, the traditional format, well, it's often been a massive hurdle. Imagine trying to find your way through this enormous, dense legal text. It feels like a labyrinth sometimes. Designed by committees, full of jargon, cross-references, sending you chapters away.
It can be incredibly daunting.
Right. It's often overwhelming, just these huge volumes filled with what feels like an impenetrable thicket of technical terms and legal phrasing. It's a classic information overload problem.
And that density, that complexity, it actually reminds me of something from the PMBOK guide that's a key standard in project management.
Oh yeah, what's that?
Well, it talks about operating in a complex environment where uncertainty and ambiguity can combine to blur causal relationships. And that fits perfectly here. When you're trying to figure out how different, intricate parts of a building need to work together, say how a fire-rated wall connects to a floor assembly, or the specific ventilation needed for a certain type of room, a purely text-based, legalistic approach can actually hide those crucial relationships instead of clarifying them.
So instead of making it clearer, it can make it muddier.
Exactly.
Yep.
It makes it really hard to define the issues clearly, anticipate potential problems, and figure out how to address them effectively. You end up with this sort of mental fog, trying desperately to build a 3D picture from fragmented 2D text.
And I bet this isn't just a problem for students or people new to the field, right? Even experienced professionals must struggle with this.
Absolutely. It's a challenge across the board. Even for seasoned architects, engineers, contractors, interpreting codes accurately can be a huge time sink. And, yeah, it often leads to misinterpretations. That PMBOK guide point about tailoring approaches for specific project environments, that really applies here too. It suggests that a rigid, one-size-fits-all, purely text-based rulebook just isn't enough for the dynamic reality of a construction project. You can't just hand someone a massive code book and expect them to instantly get every single nuance for their specific situation.
Plus, you have different teams involved. Architects, engineers, contractors.
Right, and that complicates things even more. The BIM handbook touches on this, the inherent fragmentation of communication within the AEC team. Architecture, engineering, construction. different professional roles, specialized language, distinct responsibilities.
Hmm.
These can already create communication barriers.
Okay, I see where you're going.
Now, throw an unclear or poorly communicated code requirements into that mix. It's not just a recipe for confusion. It's a recipe for expensive mistakes, delays, rework.
And the consequences of that ambiguity, they can be pretty severe, can't they?
Oh, definitely. They're far-reaching and often quite damaging. Misinterpretations lead directly to errors happening on the actual job site. They cause significant project delays. We're talking weeks, maybe months. And the rework needed to fix those mistakes. Incredibly costly, sometimes running into millions of dollars.
Wow.
Construction Management Jumpstart even points out how bad it can get if a subcontractor, maybe because they misunderstood a key code requirement related to their work, gets into financial trouble and goes bust mid-project. It can close the whole project to just tailspin.
That's catastrophic.
Imagine that financial trouble stemming directly from misreading a fundamental rule about structural integrity or fire safety. The stakes aren't just financial. It can be life or death. The exposure is enormous.
And it even gets into legal territory, right?
It does, in a very concrete way. Construction law, for example, mentions how contracts often have specific procedures for notifying people about ambiguities or discrepancies in the contract documents, which definitely includes CLIB issues. And if you don't follow those procedures meticulously, a contractor might find themselves disentitled from additional remuneration.
Meaning they can't get paid for the extra work needed to fix the ambiguity.
Exactly. They could be legally barred from claiming payment for work that was necessary because of a code ambiguity they didn't flag properly. So the challenge isn't just understanding the words, it's navigating this highly complex, legally charged, financially sensitive environment where one misstep, one missed nuance in the code can have huge professional and financial consequences.
It sounds like the whole system was just crying out for a better way, a way to cut through all that dense language.
It really was.
And that, everyone, is precisely where the visionary Francis D.K. Ching enters the picture. Faced with this, well, mountain of dense, often really hard to understand text, Ching saw the core problem: code accessibility. And he offered this incredibly elegant, truly revolutionary solution. Just look at the title of his famous book, Building Codes Illustrated. That title isn't just a name, it's a promise. It signals his whole groundbreaking approach. That single word, illustrated, that's the key. That was the beacon of clarity the industry desperately needed.
What Ching accomplished was really quite remarkable. It wasn't just about adding a few pictures here and there. His core method is both incredibly simple in concept and profoundly effective in practice. He uses this specific, highly refined style, clear, elegant, intuitively understandable drawings, and he uses them to translate that complex prescriptive code text into visual information that you can just digest easily.
It's like he turned architectural drawing into a language itself.
That's a great way to put it. It's using the power of drawing as a universal language, a direct path to understanding. If you've ever seen any of Ching's other major works, like Building Construction Illustrated or Architecture, form, space, and order, you instantly recognize his style. It's consistent, it's masterful. It really shows his deep understanding of how visual information can communicate complex technical ideas with a clarity and precision that words alone often struggle to match. It's art applied with surgical precision to technical communication.
You know, it almost feels like he was channeling a deeper architectural philosophy. It makes me think of Le Corbusier. Well, Le Corbusier talked about architecture using elements which are capable of affecting our senses and of rewarding the desire of our eyes. Forms that work physiologically upon our senses and create a state of satisfaction through understanding relationships. Ching's illustrations kind of do that for technical information, don't they? They don't just state a rule. They help you feel the space, see the requirement in its context. You grasp the relationships almost instantly, bypassing that struggle of decoding dense text. It feels like a more direct, almost sensory way of understanding.
That's a fantastic insight. His work really embodies a powerful teaching philosophy, and it aligns beautifully with broader principles of effective visual communication. Thinkers like Edward Tufte, who championed graphical integrity. Tufte famously said we should show data variation, not design variation.
Meaning the graphics should serve the information, not themselves.
Exactly. And Ching's drawings are a masterclass in this. They're meticulously crafted to clarify the data, the code requirements, not to distract you with fancy design elements or artistic flourishes that just draw attention to the drawing itself. They're like clean, transparent windows looking onto the information.
Yeah. You can really see that. He sticks to Tufte's principles of clarity, precision, and efficiency. He strips away anything unnecessary to focus sharply on the essential parts of the code. He uses techniques like really precise, consistent line weights to show different elements clearly. He uses ease of labeling, often with simple horizontal text that's easy to read and connect to the diagram. And there's a clear emphasis on causal influence. He makes those complex relationships, like how one part affects another and a fire-rated assembly, immediately visible and understandable. It's a visual language built purely to inform.
Absolutely. It's similar to another Tuft idea, using a subtle gray grid in tables instead of a darkly printed grid that distracts. Ching uses visual cues, subtly careful shading, minimalist rendering, selective highlights to guide your eye without overwhelming it. It makes the information feel transparent and accessible. It's actually a very sophisticated application of visual psychology to technical learning. As the art critic John Ruskin once observed, the eye is most influenced by what it detects least.
Ah, interesting.
Ching's genius is partly in those subtle cues, the way they lead to immediate understanding. Complex details become graspable almost without conscious effort. His work is the complete opposite of what another critic, Rainer Banham, might have called self-promoting graphics or monumental windbags, visuals that actually get in the way of the information. Ching is all about the information, delivered with unmatched clarity.
So bringing this all together, what's the impact for professionals? Ching's visual language becomes this crucial bridge, right?
A vital bridge.
It effectively closes that often huge gap between the abstract, legalistic code text and its actual, concrete application on a busy construction site. It means better, faster comprehension for a really diverse group of people: experienced architects, structural engineers, contractors out in the field, skilled tradespeople, even building inspectors doing checks. His work makes code literacy not just some ideal, but an achievable goal. It helps ensure that the rules designed for safety are actually understood and therefore correctly put into practice. He really did transform an intimidating subject into something approachable, understandable, and ultimately safer for everyone building our world.
And Ching's knack for simplifying without losing the crucial details. That's what makes Building Codes Illustrated so incredibly effective. It's especially clear when we look at specific, often very complex areas of the code. Let's take fire safety and building separations. That's a huge one. The whole point here is to meticulously control how smoke, heat, and flames move during a fire. That's exactly why openings between floors, for stairs, elevators, mechanical shafts, has such strict specific requirements. Ching's clarity makes these critical rules not just readable, but visually immediate in a way text alone just can't match.
So how does he show something like building separation, say, between different uses in one building?
Right, like mixed occupancies. Imagine maybe a shop on the ground floor with apartments above it. Ching visually explains how that requires specific fire-rated partitions between them. But what's really clever is how he illustrates that these separations aren't just about safety, though obviously that's number one. They could actually be a strategic design tool. By using these fire-rated barriers correctly, the code might actually allow you to have a larger total building area or more area for one type of use on a single floor than you could otherwise in certain construction types.
Ah, so the separation enables something else.
Exactly. He doesn't just draw the wall. He shows its function and its implication. He breaks down the requirements based on the occupancy type, the building's construction type, its height, especially focusing on shaft protection rules, which you'll find mostly in Chapter 7 of the International Building Code, the IBC.
And he gets into the real nitty-gritty too, right? Not just the general concept of a firewall.
Oh, absolutely not just general concepts. When you get into calculated fire resistances for specific materials and assemblies, Ching is incredibly precise. For example, he'll visually demonstrate the exact use of, say, 58-inch Type X gypsum board. That's a specific type of drywall with enhanced fire resistance. He shows how it's used for the non-combustible protection of mass timber elements.
Mass timber, those large engineered wood beams and panels.
Precisely. Walls, ceilings, columns made from engineered wood. And Ching doesn't just show the board, he visually includes the specific attachment method. Like how Type S drywall screws of a certain length have to penetrate the mass timber by at least an inch when they're driven flush.
Wow, down to the screws.
It's that level of detail shown graphically that makes it so much easier to grasp than wading through pages of technical specs. It really drives home the point that in fire safety, every single detail, right down to the fastener, is fundamental to how the whole system performs.
That makes total sense. It's about seeing the system, not just the parts. What about the outside of the building, the exterior walls?
Yes, it's definitely not just about the inside. Ching brings that same clarity to exterior wall fire ratings. You know how sometimes you see a building's exterior wall extending up above the roofline? That little wall is called a parapet.
Right, I've seen those.
Ching's visuals explain that this isn't just for looks. It's a critical fire safety measure, often required by IBC Section 705.6. It's designed to stop flames from easily spreading across the roof to the next building. It's like a fire wheel in the sky. He makes that function immediately obvious. He also clarifies that the internal structure bracing these walls has to meet the fire resistance ratings listed in IBC Table 601. And he highlights a really important, sometimes overlooked detail about combustible water-resistive barriers, those membranes that keep water out. In certain types of construction, type 1, 2, 3, or 4, if the building is over 40 feet tall, these barriers need special testing according to a standard called NFPA 285. This test specifically looks at how the whole wall assembly resists flames spreading vertically and sideways. It's a crucial detail for tall buildings that you can easily miss just reading the text, but Ching makes it visually prominent.
That is incredibly specific, but clearly vital. How does he handle something complex like smoke control systems in larger buildings?
Smoke control is definitely complex, but Ching breaks it down beautifully. He visually identifies all the components and how they interact. The mechanical ventilation, the supply ducts pushing fresh air in, the exhaust ducts pulling smoke out. He visually specifies critical details, like how the exhaust ducts need to be tightly constructed and must pull out at least 150% of the supply air. This creates negative pressure to help contain the smoke.
Pulling more out than pushing in.
Exactly. He also illustrates smoke traps, features designed to stop smoke moving through shafts. They need to be at least 20 inches deep and positioned no more than 6 inches below the top of the opening. He shows how supply ducts need to provide 1 air change per minute and be located near the floor no more than 6 inches up to push smoke upwards, away from people. And a really crucial point, he shows how doors, when open, must not block these duct openings, ensuring the airflow paths stay clear. Every one of these details is vital for occupant safety, and the visuals bring them to life.
Makes sense. And CO detectors.
Can't forget those. IBC Section 915 mandates carbon monoxide detectors in specific places. Group E, educational, Group I, institutional like hospitals, and Group R, residential, whenever you have potential CO sources like fuel-burning appliances or attached garages. Again, a clear, simple graphic from Ching is worth pages of dense text, instantly showing where these lifesavers are needed.
Okay, let's shift gears slightly to egress, getting out safely, and occupancy limits. These rules are just non-negotiable for safety. How does Ching simplify what can often feel like a really tangled web of regulations?
Egress rules are absolutely paramount, you're right. And Ching's explanations really clarify the core concepts. He clearly defines interior exit stairways, which are covered in IBC Section 1023. He shows they're a specific type of exit component that helps meet fundamental design requirements, like figuring out how many exits a building needs or calculating the maximum exit access travel distance. That's how far someone might have to walk before they reach a protected exit. Crucially, he illustrates that these stairways provide a protected, fire-rated path all the way to an exit discharge point or a public way, ensuring people are safe during an evacuation.
What about other kinds of stairs, or just how big a building can be overall?
Good questions. He also addresses exit access stairs, which fall under Section 119.3. Now, the general rule is they need to be enclosed, again, to stop smoke and fire spreading. But Ching visually highlights the numerous exceptions to this rule. These exceptions often apply to occupancies other than Group I2, like hospitals, and I3, like jails. Seeing that visual distinction is so helpful because it immediately tells a designer where there might be some flexibility and where strict enclosure is absolutely required, especially for protecting vulnerable populations.
And the building size limits, those tables can be intimidating.
They can be. But Ching masterfully illustrates allowable building heights and areas by essentially decoding complex tables, like IBC 504.4 and 506.2. He shows how critical factors, the construction type, from the most fire-resistive type I down to wood frame type V, the occupancy classification, like A2 for nightclubs, A3 for churches, A4 for arenas, and whether or not there's an automatic sprinkler system all interact. His drawings make it clear how these factors together determine the allowable heights in stories above grade plane and graphic allowable areas. He might show, for example, how an A2 occupancy with sprinklers, built using Type 2 construction, non-combustible, allows for certain specific height and area limits. It makes that dense tabular data instantly understandable in its real-world spatial context.
That visual translation is key. Now, thinking about the structure itself, Ching's ability to visualize loads and components is just fantastic. The basic idea is simple. Buildings have to hold themselves up, plus everything inside, and resist wind and earthquakes, but showing how.
Indeed, he's meticulous. He illustrates the specific parts of concrete floor systems, showing how beams, girders, haunches, drop panels, and capitals need to be placed monolithically.
Meaning poured all as one piece?
Exactly. Cast as a single continuous unit, which is absolutely critical for structural integrity. He clearly shows columns as vertical members, primarily designed to support axial compressive loads forces, pushing straight down on them. Then he visually distinguishes the different types of reinforcement inside the concrete. He shows spiral reinforcement, that continuously wound helix shape, which gives amazing confinement strength to columns, preventing them from bursting outwards under load. He contrasts that with ties, which are those individual hoops or rectangular loops that also provide lateral support in columns. And he shows stirrups, which are specific reinforcing bars used in beams to resist shear forces, the forces that try to slice through the beam. This level of visual detail is so powerful because you don't just see the part, you see its job in resisting forces.
And that detailed approach continues right down to the foundation, doesn't it?
Absolutely. His visuals extend right down to the foundations, drawing on his incredibly detailed work in Building Construction Illustrated. Ching's drawings clarify things like foundation walls. He explains that cast-in-place concrete walls need temporary formwork built on-site to hold the wet concrete. He depicts piers, those vertical foundation elements, maybe 12 to 18 inches across, often with a wider flared bottom for better load distribution, and emphasizes they need engineer-designed reinforcement. Crucially, he illustrates the factors that determine how big a footing needs to be. It depends fundamentally on the load coming down from the wall above, the strength of the soil underneath, its allowable bearing capacity, and the need to place it below the frost line to avoid damage from freezing and thawing. He helps you see those invisible forces and the engineering designed to handle them.
What about the walls themselves, like typical wood framing?
For wall framing, drawing from sources like fundamentals of residential construction, his distinctive style would vividly show things like ground floor wall framing supported by temporary diagonal bracing during the construction phase. It highlights that need for stability before the final sheathing goes on. His illustrations would make the difference clear between using wider 2x6 studs for exterior walls, mainly to fit more insulation for better energy efficiency, versus using standard 2x4s for interior partition walls where insulation isn't the main driver. He also gets into specialized things, like proprietary firewalls. These aren't just thicker walls, they're highly engineered systems. They might use light gauge metal studs, non-combustible insulation, multiple layers of gypsum board, and even special clips designed to actually detach during a severe fire.
Detach. Why?
To allow the structure on one side of the firewall to collapse without pulling down the firewall itself, thus protecting the adjacent building or space. It's a remarkable detail showing the depth of fire protection strategy, made clear visually.
Wow, okay, so it's all about how these pieces fit and work together. And roofs. Same detailed visual approach.
Yes, exactly. For roof framing, Ching's visuals are invaluable. He details all the parts. The roof sheathing, that flat layer, usually plywood or OSB that covers the rafters, the fascia, the trim board running along the edge of the eaves, the metal drip edge, guides water into the gutter, the rake trim finishes the sloped edge of a gable, and the barge board, often a more decorative board along the rake. He shows how they all interconnect, illustrating how each piece contributes to the roof structure and its ability to shed water. These visual guides, like in Building Construction Illustrated, make the whole assembly incredibly clear. You see how it all fits together. Similarly, for exterior walls, Building Codes Illustrated breaks down the layers. He shows the outer weather-resistant exterior wall covering, like siding or brick, then the critical water-resistive barrier behind it, like house wrap, and then the strategic placement of flashing, that thin, usually metal material used at joints, corners, and around openings like windows and doors. His drawings let you visualize where water might try to get in and understand precisely how the design stops it.
So he even makes the hidden layers visible and understandable. What about things like air barriers, which are crucial for energy efficiency but often hard to visualize?
Great point. He clarifies the concept of air barriers too, showing their role in controlling unwanted air leakage in and out of a building, which is absolutely critical for energy performance and indoor air quality. He visually contrasts different approaches. You might have an exterior solution, like house wrap, that synthetic fabric you see on buildings under construction. He shows how it needs to be carefully taped at the seams and sealed at edges to be continuous. Then he contrasts that with interior approaches, maybe using a polyethylene sheet as a vapor retarder combined with airtight drywall. His illustrations really highlight the practical challenges. How do you maintain that continuous barrier when you have electrical boxes, pipes, ducts penetrating it? These details, as noted in Fundamentals of Residential Construction, are key to making the system actually work effectively.
Okay, so even these less obvious but still vital components get the clarity treatment. Does he cover newer or more specialized things too, like green roofs?
He does, even seemingly niche or newer requirements, like those for vegetative roofs. Green roofs are made accessible. Ching illustrates the precise IBC Chapter 2 definition. A vegetative roof is an assembly of interacting components designed to waterproof a building's top surface that includes, by design, vegetation and related landscape elements. Importantly, he brings attention to the related requirements found in the International Fire Code, IFC, which directly impact the design, even if they aren't repeated verbatim in the main building code. What's really valuable there is how Ching visually integrates requirements from different code documents. That's crucial for a truly complete understanding, showing how various rulebooks intertwine. These are just a handful of examples, of course, but they really show how he makes even the most complex, nuanced parts of building codes remarkably clear, understandable, and ultimately actionable for anyone involved in design or construction.
This is where our whole deep dive into Ching's work becomes so incredibly relevant and honestly really interesting for every single professional working in the built environment today. What we've clearly seen today underlines something crucial. Code literacy isn't just a nice-to-have skill, it is an absolute non-negotiable necessity. It's simply not enough anymore to just know what the rules are, to have memorized a list of regulations.
Right, you need the context.
Exactly. Understanding the deep why behind those rules, the safety principle driving it, the structural behavior it accounts for, maybe the historical lesson it learned, that understanding is vital for every architect, every builder, every engineer. Ching's work isn't just a reference book you look things up in. It actively facilitates this deeper level of understanding. It moves us way beyond just rote memorization into a realm of genuine, integrated comprehension. It really connects with that idea from the last planner system philosophy in lean construction, which emphasizes learning how to do what we say we're going to do. It's about capability, intentionality, delivering reliably, not just passively following rules.
And that deeper understanding, that capability, feeds directly into better collaboration, which is just essential on today's complex projects.
Absolutely critical. Our sources consistently highlight the importance of the team concept, especially in design construct projects where the owner, the designer, and the builder need to work cooperatively right from the start. In that model, the contractor provides substantial input into the design process very early on. Code literacy across the entire team is fundamental for that kind of collaborative environment to even function. Everyone needs to be speaking the same language of safety, performance, and regulatory compliance.
And construction managers, the CMs, play a huge role in that orchestration.
A pivotal role. They are tasked specifically with identifying code requirements during the design development phase and helping to refine the quality standards for the project, as laid out in the CMAA Construction Management Standards of Practice.
They're like the conductors, ensuring the code's intent, that why we keep talking about, is woven through every single stage, from initial concept right through to completion, preventing those costly errors and ensuring safety throughout.
Okay, and speaking of integration and making things work better, we absolutely have to talk about the digital evolution that's completely reshaping the industry. I'm talking about building information modeling, or BIM.
Ah, yes, BIM, a true game changer.
It really is. BIM is this incredibly powerful modern tool that, as the CMAA Standards of Practice puts it, essentially brings the previously separate functions of planning, design, construction, commissioning, and maintenance management together as an integrated whole. It breaks down those silos. And it's not just amazing for design visualization, it's crucially important for code compliance and understanding as well.
It's completely revolutionary in that regard. Think about a CAD system like Autodesk Revit. It's not just drawing lines electronically, it's inherently data-based.
Yeah.
As the design develops in the model, the system can automatically generate things like a bill of quantity list of materials, as mentioned in project management and construction. If you change the design, make a wall thicker, move a window, the material lists and the 3D model update instantly.
And that data can be checked against codes?
Precisely. The digital model itself can incorporate automated code checks. It can proactively flag potential violations or designs that don't meet requirements very early in the process, long before anything is actually built on site. Huge savings potential there. The BIM handbook goes deeper, explaining BIM applications not just as single software programs, but as integrated tools, platforms, and environments. They support interoperability, meaning seamless data exchange between different software. This is vital for connecting the BIM model to specialized analysis tools, like for structural analysis, energy performance analysis, or for quantity takeoff, scheduling, and procurement systems. The BIM model isn't just a static picture. It becomes this intelligent living database that informs literally every decision.
So it's not just about drawing anymore, it's about intelligent modeling and finding problems before they happen?
Exactly that. And within the BIM world, you have model review tools. These are used for critical integration tasks, like coordinating different systems, structure, plumbing, electrical, simulating the construction schedule visually, and even simulating building operations. A key function here is clash detection. Famous examples like the Castro Valley Medical Center project or the Crusoe Bridge use software like Navisworks for this.
Clash detection, like finding where things literally collide in the model.
Yes. Finding where, say, a large heating duct is modeled running straight through a main structural beam, or where a fire sprinkler head ends up being blocked by a light fixture. BIM finds these clashes digitally, early on. Identifying these conflicts in the model saves immense time, money, and prevents incredibly costly, potentially dangerous rework out on the actual construction site. The BIM handbook even talks about the need for a designated BIM integrator, someone whose job it is to manage the model's integrity and having a virtual plan room on site. This allows everyone to monitor and update the central model in real time as things progress. And it requires really clear definitions of who is responsible for updating what in the model: designers, contractors, subs, even potentially the building official reviewing it. It creates this truly integrated ecosystem where code compliance becomes a dynamic, ongoing process, not just a final check.
That's fascinating, and I heard something about 4D.
Right, 4D BIM. That integrates the 3D model with the fourth dimension time. It ties the construction schedule directly to the BIM model. This allows teams to visualize the construction sequence, see how schedule changes impact the physical progress, and critically, figure out how to sequence the work efficiently and in a code-compliant manner. It's incredibly powerful for planning and coordination.
So, wrapping all this together, where does it leave us? Ultimately, it feels like it comes back to something profound that the architect Louis H. Sullivan reflected on. He talked about the power of man, the living power to wish, to will, to do.
A powerful quote.
He spoke of humans making paths, laying rails, building engines that others might pass. In our world, the building industry, it's the architects, the engineers, the builders, armed now with clearer understanding, the kind of deep understanding facilitated by visionaries like Francis D.K. Ching, and amplified by tools like BIM who are harnessing that immense power. They're creating structures that aren't just functional or aesthetically pleasing, but are fundamentally safe, designed to be resilient, built to endure.
It ensures that the core function, the safety aspect, is robust.
Exactly. It's about ensuring that let's call it the typewriter function of a building, as Le Corbusier somewhat provocatively described it. Its essential mechanics, its efficiency, its fundamental safety is as serviceable, as reliable, as humanly possible. It needs to be understood and implemented effectively by everyone involved.
Which contrasts maybe with Ellen Richards' more poetic idea of the house as a home is merely outer clothing.
Right. While that emotional, aesthetic clothing of a home or building is incredibly important, Ching's work and the clarity it fosters ensures that the inner workings, that vital framework of safety and code compliance beneath the surface, are not just robust and well understood, but also beautifully clear. It's like bringing light directly onto the blueprints of safety itself. And that brings us to the end of another deep dive. We've taken quite a journey today, haven't we? We explored the foundational, often kind of hidden importance of building codes. We wrestled with the real challenges posed by their traditional, often very dense format. And we celebrated the truly pivotal, transformative role of Francis D.K. Ching in making these critical regulations accessible to potentially everyone through his clear, elegant, and universally understood visual language.
His contribution really can't be overstated.
It really can't. And what we've hopefully reinforced today is that code literacy isn't just about compliance. It's not just about checking boxes. It's about cultivating a much deeper, more intuitive understanding. It's about grasping the why behind the what. And that deeper comprehension leads directly to better design decisions. It leads to significantly enhanced safety for everyone who uses these buildings. And ultimately, it leads to more resilient, more thoughtfully designed, and more sustainable built environments for all of us. It's really about empowering every professional in the AEC industry, architecture, engineering, construction, to truly master the why behind the what, fostering this culture of informed excellence and responsibility. So as you go about your day, maybe reflect on this final provocative thought. How many other fields out there, fields burdened by their own dense, intimidating technical information, could profoundly benefit from the kind of visual revolution that Francis D.K. Ching brought to building codes? What complex, maybe opaque subject in your world, your profession, your area of interest could be illuminated and transformed by the power of elegant, intuitive illustration? Imagine allowing more people to truly master that knowledge and apply it with confidence. The principle that Ching exemplified, the power of clarity, it extends far beyond concrete and steel and gypsum board. It's a universal lesson in the power of clear, visual communication to unlock understanding, foster safety, and ultimately drive progress.